Hello everyone, and welcome back to the good stuff that we've been doing. Today in this video, we are told that a certain sequence of numbers a sub 0, a sub 1, a sub 2, and then going further satisfies the condition that a sub n plus 1 is equal to 2a sub n plus 1. We are told that n is bigger than or equal to 0 and a sub 0 is 0, and we are required to find this sequence. Just like all problems on recursive sequences, we try to find maybe like the first 2 to 3 values of the sequence. So let's take n equals to 1. Say n equals to 1. This gives us that a sub 1, we have to start with 0. So because n is bigger than or equal to 0, so let's say n equals to 0. Then a sub 1, this is 0 plus 1 is a sub 1, is equals to twice a sub 0 plus 1. But we are told that a sub 0 is 0, so this is just equals to 1. This is just equals to 1, so a sub 1 is equals to 1. What about a sub 2? Well, we let n equals to 1, that means a sub 2, because 1 plus 1 will be 2, will be twice of a sub 1 plus 1. That means a sub 2, what is a sub 1? A sub 2 will be 2 plus 1, that will be 3. So now whatever the case where n equals to 2, that will give us a sub 2. Nope, 2 plus 1 is 3, so that will, a sub 3 will be twice of a sub 2 plus 1, that will be twice of 3 plus 1, so that would be 7. Here we get that a sub 0 is 0, a sub 1 is equals to 1, a sub 2 is equals to 3, and a sub, of course, a sub 3 is 7 as well. So these numbers actually resemble the powers of 2 minus 1. So this is just 2 to the power of 1 minus 1, this is just 2 to the power of 2 minus 1, and this is 2 to the power of 3 minus 1, or not equals to. So this is 2 to the power of 3 minus 1. So we should conjecture that a sub n should be equals to 2 to the n minus 1, and we can prove this by induction. But in this problem we are going to solve this using the method of what we call generating functions. So we're going to use what we call generating functions, okay? Generating functions to solve this problem. We're not going to try to prove this by induction, but you can actually do this by induction. Now let's proceed further. Moreover, if you want to try to do this by induction, start with the base case, then build up the cases there. It's actually pretty easy. So, but let's try to solve the sequence by generating functions, and this is the general formula for the sequence. A sub n plus 1 is equals to twice a sub n plus 1. So let's define g of x to be the sum from n greater than or equal to 0 of x a sub n of a sub n x to the, is called the generating function for this sequence. Because in this case now, for g of x, if you observe that g of x, the coefficients of g of x are the n term of this sequence, so g of x, the expansion of g of x will be a sub 0 plus a sub 1x plus a sub 2x squared. So the coefficient of x to the n is a sub n. So if we can find the form, if we can find explicit expansion for g of x, if we can find it, then we are sure that we have found the n term of this sequence. So how do we do? See, let's multiply this a sub n plus 1 by x to the n, both sides of the equation by x to the n, and let's sum it. So if we multiply a sub n plus 1 by x to the n and sum from n equals to 0, 1 up to until n, right? If we sum this to up until infinity, what we get is that a sub n plus 1 multiplied by x to the n for n greater than or equal to 0 would be equals to, this will be from a sub 1 plus a sub 2x plus a sub 3x squared plus a sub 4x to the 4th power, and then we'll continue this way. But notice that here g of x is defined to be a sub 0 plus a sub 1x. So what we're going to do is that we're going to add a sub 0 and divide by x. So this will be a sub 0 plus a sub 1x, like so we multiply by x. This will be a sub 2x squared. Initially we had a sub 2x, but now we have a sub 2x squared plus a sub 4. Okay, this was supposed to be cube, x to the 4th power. So if we continue further, at some point we have to subtract a sub 0 and then we divide everything all by x, because we have to subtract a sub 0 because we added a sub 0 here, so we have to subtract it from this other side of the equation. And then what we'll do next is that this is equals to g of x minus a sub 0 over x, but we thought that x sub 0 is 0, so this is just equals to g of x all divided by x. So here we have found a very neat formula for this sum from n of a sub n plus 1 as n greater than or equal to 0 of x to the n. Now we are going to do the same thing to the right hand side of our equation. Let's flip over to the next section. So we have a sub n plus 1 equals to twice of a sub n plus 1. Here a sub 0 is equals to 0 and n is greater than or equal to 0. So when we sum everything up, let's sum the left hand part. That would be like we are going to sum twice of a sub n plus 1 x to the n for n greater than or equal to 0. That would be twice the sum of a sub n as n greater than or equal to 0 of x to the n, plus we are going to be summing x to the n for n greater than or equal to 0. This will be twice of g of x, I believe, plus now this sequence will be 1 plus x squared plus s cubed up until infinity. Then this would all become 2 times g of x plus 1 over 1 minus x. So our equation becomes, thus this equation, this implies that this particular equation, which is a sub n plus 1 is equals to twice a sub n plus 1, gives us that g of x over x is equals to twice of g of x plus 1 over 1 minus x. Let's try to see if we can find a good formula for g of x here. So let's subtract g of x. So let's multiply both sides by x. So that means g of x is equals to 2x g of x plus x over 1 minus x. So therefore g of x 1 minus 2x is equals to x over 1 minus x. So that means g of x would be equals to x over 1 minus x, and then we'll have 1 minus 2x. Now we are not done with our problem. Now the next step to do is that we're going to express g of x in partial fractions, and once this is done, we are going to pick out the coefficient of g of x in the expansion. So let's flip over to the next board. So, and to do this, we're going to expand g of x in partial fractions. So let's flip over to the next page and see how we can do this. So here we see that g of x is equals to x all divided by 1 minus x and 1 minus 2x. Well, I won't give the details, but we can write this as x multiplied by 2 all divided by 1 minus 2x minus 1 over 1 minus x, and this would be x. Then we have a 2 multiplying 1 minus 1 plus 2x plus 2 squared x squared plus 2 cubed x cubed up until infinity, and then we are subtracting by 1, right? Yeah, 1 plus x squared plus s cubed plus up until infinity. So that will give us 2x plus 2 squared x wait, hold on. This will become 2 squared x, and then we'll have a plus 2 cubed. Oh yeah, that will be 2 cubed x squared plus 2 cubed x squared, then plus 2 to the 4th power x to the 4th. Then we are subtracting x plus x squared plus s cubed plus up until infinity. So this will be, what's the coefficient of x? This will be 2 minus 1 multiplied by x. 2 minus 1 multiplied by x. This will be plus 2 squared minus 1. Hold on. That would be 2 squared, or 2 squared minus 1 multiplied by x squared. That would be plus 2 to the 3rd power minus 1 multiplied by s cubed. And this is how the pattern will continue. So this means that g of x is equals to 2 to the n, the sum of 2 to the n minus 1 x to the n from n greater than or equal to 0. But we know that this is equals to the sum of a sub n from n greater than or equal to 0 of x to the n. Therefore a sub n is 2 to the n minus 1, and this is the general formula for the sequence we are actually looking for. And this solves the problem completely. So thank you for watching, and please do subscribe to the channel. Have a nice day. Bye.